Alright, now for number 11 through 20. If we look at this problem, make sure you know if you have a plus or minus, I just want you to take the derivative of whatever this function is, and then derivative of whatever this is, and then just put a plus or minus in between them. Don't make it more challenging than it is. Just treat it like two separate problems. The derivative of 5x is 5. The derivative of 3 sine 7x. Okay, this, we have some chocolate M&M here. Our outer part is 3 sine, our inner part is 7. So the derivative of negative 3 sine would be negative 3 cosine. Don't chew the chocolate, so you have to have 7x. But then times the derivative inside, which is 7. So if we simplify this, we just have 5 minus. Multiply your algebra together. 3 times 7 is 21 cosine of 7x. So here's your answer. Okay, this quotient rule, we do not have to use, do not use the quotient rule because you don't have a function of x over another function of x. This can just be a rewrite problem. So don't make it harder than this. Rewrite it as 5 times 3x plus 1 to the negative 4. Notice I wrote it on the same line because I don't want you to think you're done with the problem like you did on the quiz. So when I go to take the derivative, g prime, I bring down its chain rule. My outer function is this 5, the negative 4. The negative 4 times 5 is negative 20. Subtract 1, negative 4 minus 1. Be careful there, it's negative 5. Don't chew the chocolate, so it's still 3x plus 1. But then you have to multiply times the derivative. Let the chocolate melt. You're going to eat it all, so don't forget to chew the chocolate. Negative 20 times 3, negative 60. 3x plus 1 to the negative 5. This answer is perfectly acceptable. Or you could do negative 60 over 3x plus 1 to the positive 5. Either of these answers is correct. Okay, number 13. I can either use the product rule or the quotient rule. Either one. If I do the quotient rule, I have the top and the bottom. Derivative of the top is 1 times the bottom minus the derivative of the bottom, which is negative sine, times the top all over the bottom squared. So if we simplify this, we have cosine x plus, I'm going to put the x in front of the sine x, like algebra in front of the trig, over cosine squared x. This is completely fine. Or you can write 1 over cosine of x equals secant of x. So this is really x times secant of x. So I could treat it as the product rule. Derivative of the first is 1 times the second plus the derivative of the second, which is secant x tangent x, times the first. This answer and our other answer are the same. We could do some trig manipulation to figure that out. It's because cosine over cosine squared simplifies to secant, and sine over cosine squared simplifies to secant tangent. Okay, this one we have no choice but to use the quotient rule. So, because we have two functions of x, they both have multiple terms. The derivative of the top, 4, times the bottom, minus the derivative of the bottom, times the top, all over the bottom squared. Now don't worry about the bottom being squared, keep it like that. The top, let's multiply out 28x minus 14, and then a minus 28x plus 21, all over 7x minus 2 squared. 28's cancel. We have 21 minus 14, so we get a 7 over 7x minus 2 quantity squared. Number 15. Okay, two separate problems. Don't get confused. This is not a product rule between these two. One problem and another problem. For the first part, we need to do the product rule. The derivative of the first, 5, times the second, plus the derivative of the second, which is negative cosecant squared x, times the first. So product, don't forget product plus. Now over here, you just treat it as two separate problems. You got to answer here, you got to answer here. The derivative of cosecant is negative cosecant x cotangent x. I simplify everything. I have 5 cotangent x. Negative and a 5x give me a negative 5x cosecant squared x, and then minus cosecant x cotangent x. So this is your answer. Okay, number 16, a lot of people messed up on the quiz. Number 16, I go to rewrite it first. It's 2/7 times x to the negative 4. Okay, now when I go to take the derivative of this isn't the answer. I haven't taken the derivative yet. I'm going to use the power rule. Bring down the negative 4. Negative 4 times 2 is negative 8. So negative 8/7 x to the subtract 1. Negative 4 minus 1, negative 5. This right here is your answer. Or you could write negative 8 over 7x to the 5th. Either answer. Okay, here's a peanut M&M. I know it's our favorite. The 4 is not included in the parentheses. So anytime you have a coefficient out here, it's not included in the parentheses. So we have, I'm going to change the colors, 4 and this thing cubed. Our chocolate is secant, and our peanut is 2x plus 1. So when I go to take the derivative of this, we do the derivative of the outside first. So 3 times the 4 gives you 12. Lower the exponent by 1, so we get 2. And then you have secant. Don't chew the peanut. Don't change it. It's 2x plus 1. Now, I really, really want you to do all of this on the same line, because otherwise you're going to get really confused. So on the same line, you're continuing the chain. Multiply by the derivative of secant, because it's the next layer. Secant tangent. Now, again, don't change the peanut to an almond. We keep it the same. And notice there was 3 layers. We took care of the cubed, the secant, and now we gotta take care of the last layer. What's the derivative of the 2x plus 1? 2. So looking at all this, we can combine 12 times 2, and that gives us 24. Notice we have secant of 2x plus 1 squared and secant of 2x, so that means we have 3 of them all together. And tan of 2x plus 1. So here's our answer. Okay, number 18, we can either do product rule or quotient rule. If we brought this up, we could do product rule. I'm just going to do quotient rule. So we have derivative of the top, which you have a sign on the outside of 5x on the inside. So the derivative of sign is cosine. Don't chew the chocolate, 5x, but then times 5. So the chain rule. Derivative of the top, and then times the bottom, minus the derivative of the bottom, times the top, all over the bottom squared. So if we clean this up, we have 5x squared cosine of 5x minus 2x sine of 5x over x to the 4th. Or you could factor out an x from each one of these and do 5x cosine of 5x minus 2 sine of 5x all over x cubed. You factor out an x from each thing. You have to be able to have an x here and here to be able to do this. Okay, last 2 problems. We have number 19, chain rule going on. So our outer function here is the 8th. Outer function here is the 12th. So bring down the 8, multiply it by the 5. So we get 40. Lower the exponent by 1, so it's 7. Don't chew the chocolate, but then multiply times the derivative of the inside, which is 2x. And a plus, like 2 separate problems, you're just adding them together. 12 times the 3 gives us 36. Lower the 12 by 1, so you have 11. Don't chew the chocolate, and then times 7. So we get 80x times x squared plus 4 to the 7th plus 36 times 7, what is that? 21, 22, 52. 7x minus 5 to the 11th. Here's our derivative. Then our last answer, real simple. Bring down the 7. 7 times 6, 42. Lower the exponent by 1, so it would be 6. Don't chew the chocolate. Times the derivative of what's inside. So we get 22 times 3 being 126. X plus 4 raised to the 6. The end.